Hello, welcome to question 9 of this exam practice medley. First of all, this is another question that I long to see see it come up in the exam. It's about the fluid flow in tapering pipes, and if you like, you can refer this topic in your revision guide, page 31. So let's take a look at how we solve this problem. So first of all, just to remind you, the tapering, okay, tapering, either you can say, so if something that changes its size is called tapering. Another way to taper could be like this, using staircase approach, okay. So that's also tapering. It doesn't have to be a straight line. So if this is the outlet of a pipe, or inlet and outlet of the pipe, it might be a horn type or cone type. It's a tapering. Okay. So it's given you the density, and then we need more information, don't we? So first of all, let's go to the next page. Let's go here. Okay, so we have more details about the pipe and some more extra parameters. So we are asked to calculate the cross-sectional area of the outlet. Okay, so I'll explain to you about the physics behind it, but all we need to do is find the cross-sectional area of the outlet. Well, it tells you the outlet is written here is basically a circle, okay, on the outlet, and the circle looks like this. So so the area is a circle, and the formula pi r square sounds like area to me, doesn't it? Yeah, so pi r square, or you might learn the method which is the pi d, using the diameter. So let's go for the radius for now. So pi half, so this is the diameter, so radius is therefore half of the diameter, so that's 30 millimeter. So that's pi times 30 square. Put that in the calculator. In fact, because it's going to give me decimal number, I don't really want to use decimal number because I'm going to need this number for my next calculation. So what I tend to do is I do 30 times 30, which is 900. And then I write it in terms of pi, so 900 pi for the time being. Okay, so 900 pi millimeter square. Okay. Right, so here we are. So calculate the mass flow rate. Now, in the revision guide or in the lesson, if you remember, the formula we use for the mass flow rate is got a m and a dot at the top. That's what the mass flow rate is. Now, that is set to change depending on which point you are at. Okay, the mass flow rate here will be different to here, but the flow velocity may be uniform. Okay, so lovely, in the exam they tell you the formula as well instead of you going into the formula sheets. I'm not sure if this is actually in the formula sheet, but it's given to you now. So that m with a dot at the top is that. Okay, now we know the density is given to us in the question. The area, we just worked that out, and this is the velocity at the point of the at the outlet. Okay, so therefore all I have to do is to say the m dot, which is the mass flow rate, is density. Let's just quickly go back. Is have I got it still? Okay, I think I've lost it. So therefore, let's go. So it's 1000. Okay, so let's move that up a bit. Okay, so let's start again. So m dot mass flow rate is equal to the rope 1000 times by the area we just worked out, which is 900 pi, times by the velocity, okay, okay, which is 2 meters per second SI unit. Now, just to quickly remind ourselves just what I said earlier on. So if I had tried to work out the mass flow rate here, because the area is going to be smaller than the outlet, that number is going to be smaller. So my mass flow rate is expected to be smaller answer than at the outlet, which has a bigger area. Okay, so let's just put that in the calculator then, and then that will be your answer. So let's go here. Okay, so clear that. So 1000 times 900. So I think it will work if you just put 900 pi times 2, and that gives me that amount. Okay, so is also, just to also point that out, the mass flow rate is also in kilogram per second. So if you think about it, this is meter per second, and all this will be the meter will cancel out, so that leaves you with just the kilogram per second. Okay, so 5654866.78 kilogram per second, and that is 2 decimal place. I've rounded to, so make sure you specify that to the examiner. Okay, so let's check the answer. Is that what we got? Number 9, isn't it? Okay, so we've got, I see what I might have. Let me just double check. 5 point. Okay, so what have I done? I haven't changed. Yes, I didn't use the SI unit there. So so that was one extra step then. So let's just go back to this. Because that was in millimeter per second, millimeter square, so the 900 pi area was in millimeters square. So to change that into meter square, so how many millimeter is in a meter? Well, is 1000 millimeter. But how many millimeters square is in a meter square? You have to times that. You have to square it. Okay, so therefore it's actually equal to 1, 2, 3, 4, 5, 6 millimeters square. So therefore, what I have to do is to divide that by 1, 2, 3, 4, 5, 6, 0, 1 with 6 zeros, which is 1 million, and that would give me the answer in meters per meter square. So so if I change that, so let's get rid of that. So that's not the right answer. So what I haven't done is I haven't divided by that number, so I can do that now. So I go 1, because 60, I move the decimal point 6 places. 1, 2, 3, 4, 5, 6. So the answer is 5.65 kilogram per second, 2 decimal place. So I think that's the answer on the mass scheme. It's 5.65. There we are, kilogram per second. Okay, sorry about that. It's nice to see how one makes an error actually. So that way, nothing's always perfect. So if I have done this exam, I probably have lost myself a mark. So also just to point out, had I written this as my final answer, I would have only lost 1 mark, because I have carried this wrong answer through, but I've done the correct working. So I would have got 2 marks anyhow, but I would have taken a mark off either here or here, but not both. Okay, so thank you very much.